Okay, so now we're on 7.5, finding angles and solving right triangles. So for the past three sections on sine, cosine, and tan, all we've been doing is solving for sides. So from 7.2 to 7.4, that's the three sections there, we've been solving sides. And in this section, we are going to learn how to find angles if we know two of the sides. Now it says that we're going to require an inverse operation, and to find the inverse operation on your calculator, you just need to find the second function feature and then hit the sine, cos, or tangent button after you hit the second, and you're looking for these ones: sine -1, cos -1, and tangent -1. Okay, this notation, the way that we write it, is like a -1 in the power. It's not an exponent, okay? So just jot that down so you remember. It's not an exponent, even though it looks like one. It's a symbol for inverse. And inverse just means like opposite. So like the inverse for times is divide, and the inverse for add is subtract. So it's all about opposites. So the inverse for sine is second function sine, and the inverse for cos is second function cos, and the inverse for tan is second function tan. So we will only use the second functions if they are asking you to find an angle, okay? So like right here where it says calculate each angle, what they will do here to almost to cancel the sine, you have to do sine -1 on both sides. So sine -1 of sine, they cancel each other. And whatever you do to one side, you have to do to the other. And then it's going to spit out a number from your calculator, and then you can round it, and you have, a degree. So when you use the second function on your calculator, it will give you the angle, call it theta, in degrees. Okay. And here, if they use cos, notice they use second function cos, and then they round. So for number one, all you have to do is second function sine, insert the ratio. For B, second function cos, insert the ratio. Second function tan, insert the ratio. And they're doing another sine for some reason, not sure why. Alright, so I'll just type these into the calculator. 0.5491. This one was after rounding 33. Second function cos, 0.8964. This is 26. Second function tan, 2.3548. This is 67. And the last one, second function sine, 0.9998, is 89 degrees. Alright. In a right triangle XYZ, the ratio of the side opposite x to the hypotenuse is 7/8. What is the approximate size of angle x? So an easy way to solve this question is to use the keywords that they've given us. They've given us opposite and sine, or pardon me, opposite and hypotenuse. And we know that the opposite and the hypotenuse is with the sine ratio. So I know that sine angle x, that's what we're trying to find out, is equal to 7/8. So to solve this problem, we do second function sine, and we insert the ratio into the brackets. Now, depending on your calculator, things will be different. My recommendation is that you use the brackets, and again, depending on your calculator, this is going to be different. Some calculators, you need to figure out what 7 divided by 8 is, and then press second function sign. And some calculators, you need to hit second function sign first, and then use brackets of 7 divided by 8. So if you're unable to get 61 on your calculator, you need to see a teacher and get some help. Okay, question 3. What is the approximate size of an angle in a right triangle if the ratio of the side opposite to the side adjacent is 15/8? So opposite and adjacent, we know that that's going to be tan. That relates opposite and adjacent.
Jacqueline, please come to the office and meet your sister. Jacqueline, come to the office, please.
So we know that tangent of our unknown angle, which we'll call x, is equal to 15/8. So second function tangent of 15 divided by 8 will give us our angle x. So second function tan, 15 divided by 8, I'm getting 62 degrees. Okay, a couple pages over, we're on number 4. It says, what is the angle of depression from the top of a 65-meter cliff to an object 48 meters from its base? So draw in your cliff. It's 65, this distance, 65 meters. And there's an object, so we'll make a box or something. There's an object that is 48 meters from the base. So what we can do is make the right triangle. We know the right angle's right here. So let's just find this angle x because it's the angle of elevation. And I know that the angle of elevation is equal to the angle of depression. So using my labels, 65 is straight across the angle, so that's the op. Straight across the 90 is the hype, which I don't know anything about, so ignore it. And 48 is the adjacent. So second function tan of the opposite divided by the adjacent, and this should equal my angle x. So second function tan, 65 divided by 48, and I got 54 degrees for an angle of elevation, which I know is the same as the angle of depression. So I can say, correct, I understand angle of depression. And the angle of depression, of course, is from a horizontal line, and it would be right there. So 54 degrees. Let me color it in purple. That's the angle right there. Okay, next one says, at what angle to the ground must you place a support if it is 6.8 meters long and must reach 4.2 meters up the side of a tower? Okay, so we got the side of a tower here, and they're putting a support next to it. And they say the support is 6.8 meters long, and it must reach 4.2 meters up the side of the tower. So the tower must go on. Here's the tower. This distance is 4.2 meters. And we make our right angle triangle like this. They ask us what is the angle to the ground, so that's in there. So they want us to find that angle. So straight across that angle, 4.2 is the op. Straight across the 90, that's the hype. And they didn't tell us anything about the adjacent. So the formula that does op and hype is sine. Let's call this angle unknown x. And it equals 4.2 over 6.8. So if you don't know the angle, remember it's just the second function of the ratio. So 4.2 divides 6.8, and then we'll use second function sine. And I see that x is 38 degrees. Okay, so this problem's already been drawn for us, and they're just asking us to find the angle. So all we have to do is label and then second function, whatever trig formula it is. So using this angle, straight across is the op. Find the 90 straight across, that's the hype, and here's your adjacent. Notice I don't know anything about the op, so I have to use adj and hype, which is the cosine of angle H, equal to 5 over 8. So second function cos 5 over 8 will equal the angle H, and H is 51 degrees. Okay, new skill, working with ratios to solve triangles. So to solve a triangle, and I'll just jot this down for you, solve triangle, you need all angles and all sides. Often the angles, you can use the 180 rule for a triangle, that all angles in a triangle add up to 180. And often with sides, you can use Pythagoras. If you know two of the sides, you can get the third with Pythagoras. So let's take a look at number 7. Oh, it's asking us to do it without the Pythagorean theorem. So let's identify what we know. Using the angle 48, 5.4 is the op. Using the 90 degree angle, we know that R is the hype, so that must mean Q is the adjacent. So if I want to find the adjacent using the op, I'll have to use tangent. So tangent of 48 over 1, because tangent relates the opposite divided by the adjacent, and then cross multiplying, 5.4 times 1 divided by tan 48. Get Q is equal to 4.86 meters. So let's just round that up to 4.9 meters. And so now I have Q. If I want to get R, and using the op as well, so using the op, which is 5.4, and the hype, which is R, op and hype, that is sine. So I'll need to use sine of 48 over 1 equals the op, 5.4, divided by the hype, which is R. Cross multiply like this. 5.4 times 1 dividing sine 48. R is 7.3 meters. So now I have all the sides. All sides. Check. And now I need all the angles. So we got this angle is 48 and this angle is 90. So all we need to do is get this angle here up at the top. And to get that angle, you go 180, take away 90, take away 48, and you get 42 degrees for the angle Q. Okay, because all the angles in a triangle have to add up to 180. I know that this one's 90 in the corner, this is 48 in the corner, so subtract those from 180 and you get 42. So now I have all angles. Check. Okay, number 8 says that two equal angles of an isosceles triangle are each 70 degrees. Determine the measures of the rest of the triangle if it has a height of 16. So notice that this triangle's already been drawn for you. I don't think it's in your book, so you'll need to copy that down. Isosceles triangle, this sometimes comes up in trig. It is when two sides in a triangle are equal. So it looks like this and this are the equal sides. And the two equal angles would be in the corner. So this one's 70 and this one's 70. And what you have here is basically two congruent triangles. So this pink triangle is the exact same as this blue triangle. And the reason we split the isosceles triangle into two is so that we can use this right angle right here. The height is always at a right angle to the base, and the height is 16. So it says determine the measures of the rest of the triangle. Alright, so I'm going to break down this problem into the right angle triangle. So I know that this is 70 down in the corner. And I can find this hypotenuse right here using 16, which is the op. So I can use sine of 70 over 1 equal to 16 over hype. And I can solve for that long side there. So 16 divided by sine 70 is 17. So I know that this is 17. And if I want to solve for the short side of the triangle, which is down here in green, I can use the short side version of Pythagoras. So I'll call that down there A. A is equal to the square root of the long side squared, take away the other short side squared. And that is from the 7.1 lesson if you need to re-watch that one. 17 squared take away 16 squared, all in a square root house thing, is 5.744. So they want us to determine the measures of the rest of the triangle. So let me just redraw this triangle so it's less messy. So we know that's 70, that's 70, this is 16, this is 16. And I know that the half distance is that 5.744. So I'll times that by 2, and I'll round it up. I got 11.5 for the full distance across. So 11.5 for the full distance across. So the only thing that's left is this missing angle at the top, which I can go 180, take away 70, take away 70, which is 40. Okay, this looks confusing. It says the length of the rafter is 5.5, so that's over here. And the side height of the building is 3.5. That's over here. Determine the width of the building and its total height. So to determine the width, all the way across like that, I'm assuming they want us to find out this distance and then times it by 2. So let me blow this up. This is 15 degrees here. And this would be an adjacent. This is an op. This is a hype. And I want the blue adjacent, and I have a hypotenuse. So let me use the cosine relationship, which relates the adjacent in blue to the hypotenuse, which is 5.5. Cross multiply. Cos 15 times 5.5. I got 5.31259, bunch of decimals, so I'll times this by 2. And then I'll round. I got 10.6 yards for the total distance across. So I know this is W. Now they want us to find the height. So I'll highlight that in red. I'll use the exact same 15 degrees and 5.5 yards, but instead of using cos, because I want the op, I'll use sine. And sine 15 relates the op to the height, which is 5.5. Cross multiplying again in the exact same fashion, sine 15 times 5.5, and I got an op of 1.42. So to get the total height, I would just take the 3.5 yards, which is right here, and add it to the 1.42. And then I will round, and I got 4.9 yards for the height. So not too bad, not too bad. And 10 and 11 want us to solve some more triangles, and then there's 12. So we've got 3 more to go here. Alright, so to get this hypotenuse, it's the long side, so I'll just take the other 2 dimensions, square them, and add them. So 2.8 squared plus 1.5 squared. Square root that answer, and I got 3.2 meters for the hypotenuse. To find this angle at R, I'll use second function tangent, because 1.5 is op and 2.8 is adj. So second function tangent of 1.5 divided by 2.8. Second function tan, 1.5 divided by 2.8 is 28 degrees. And if I know that this angle is 90, and I have to start at 180, take away 90, so it's definitely going to be 90 take away 28. And this is actually a shortcut method. To find the 2 acute angles, you know, they have to add up to 90 because this one down here adds up to 90. So R and S have to add up to 90. So if I know R is 28, subtract 28 from 90 and I get 62. That triangle's done. This triangle down in the bottom here is a short side Pythagoras, so I will start with the hypotenuse and subtract. Remember, that's from the first lesson. 9.5 squared, take away 6.8 squared. I got 6.6. And to find angle M here, I'll use second function sine because 6.8 is op and 9.5 is hyp. So 6.8 divided by 9.5 using second function sine, and I got 46 degrees after rounding. Subtract from 90 to get L, and L is 44. So there's L, and there's M. On to number 11. It says, what height is a pole and how far away from its cable? The angle is 25 and the cable is 18. Okay, so H is op. We have a height right there. So I go second, or I'll just use regular sine of 25 because I know the angle and I just want to find a side. Cross multiply, 18 times sine 25. So the height is 7.6 meters. And now that I have this side, I can do a short side Pythagoras. So 18 squared take away 7.6 squared. All in the square root house, and I get that this is 16.3. So D is 16.3, H is 7.6. So that question's done. It's not asking for this angle, but I know that 25 and some other number have to add to 90, so that is up there as 65. Moving along, we're on to question 12. And this looks like a couple similar triangles. Let's see what we got here. Find A, B, C, and D. So I can find A and B pretty quickly here using 40 and 15. So let me start with sine 40. That will relate the op to the hypotenuse, which is A, on this little triangle. So I'm just working on this little triangle right now. So cross multiplying 15 divided by sine 40. A is 23.3 centimeters. Do something similar for B. So I'll use tangent of 40 because it relates the op, which is 15, to the adj, which is B. So 15 over B, op over adj. So 15 divided by tan 40, and I got 17.9 for B. Now what I'm going to do is I'm going to erase all this stuff. And now I'm going to focus on the triangle at large, like this large triangle. And I'll switch colors. So now if I use 40 and sine, it's now going to relate this opposite side, 25, to the hypotenuse, which is this whole thing. And then all I have to do is subtract off A to get what I want here, which is C. So take the big hypotenuse from the big triangle using op 25, subtract A, and I'll get this little piece C. Cross multiplying 25 divided by sine 40. I get that the height is 38.9. And it's exactly the same for tangent, same idea. So tangent 40 over 1 equals op 25 over adj. Now I'll be solving for this big distance on the adj. I will subtract B so that I can get D down there. Cross multiplying 25 divided by tan 40. I got the adj is 29.8 centimeters. So to solve for C, I will go hype, the big hype, take away A. So 38.9 take away 23.3. So C is 15.6. And to get D, I'll take the big adj and subtract B, which is 29.8, take away 17.9, which is 11.9 centimeters. So that's it for this lesson. Practice your skills is your homework, and take care.